Welcome to Pravdan Tutorials. Please kindly subscribe. Thank you.
Everyone, and welcome once again to Pravdan Tutorials. This is a start of a new series, and our focus in this series is going to be on sets. So today, basically, we'll be looking at fundamental examples of sets, part 1. Okay, so basically, what is set? What is set? A set is a collection of objects. What are these objects we are talking about? For example, we can use the symbol, always capital letters, let's say A, for example, to depict a set. So we can say set A equals, okay, as an example, let me write 2, 4, 6. So in this example, let me explain to you. First, we have number 2, number 4, and number 6 inside the bracket. These are referred to as elements or members. Each of these is an element or member of set A. And you will notice that each of these elements is separated by a comma. Take note of that, separated by a comma. And lastly, this is the type of bracket that is used. It is referred to as a curly bracket. Okay, so this is a curly bracket. Some will call it set bracket, or even you can call it braces. Okay, so this is the type of bracket that is used, that contain the elements or the given member of a particular set. I'm going to take you through two types of sets. There is one that we call the finite set, and there is one that we call the infinite set. So what is the difference? In a finite set, for example, just like A equals, as we did previously, 2, 4, 6. Take note that cardinally you can count the number of elements in a finite set. For example, the number of elements we have here is 3. 2, 4, and 6. The number of elements is 3. When you can count the cardinality of a set, it is referred to as a finite set. Another point is that for a finite set, it has an end member. You know the last member or the last element. In this set A, the last element or member is 6. So this is a finite set. However, in an infinite set, let's say set B is equals to 2, 4, 6, dot. In an infinite set, you do not know its cardinality. You don't know the number of elements in that set. And such elements has an end shown as dot, like 3 dots. These 3 dots refers to as what we call ellipses, which simply means it continues. Okay, so in this case, when you have this type, it is referred to as an infinite set. So if you follow through, I'm sure you're going to understand what we are doing. There is something we also call a set builder notation. How does it work? For example, let's say we have something like this. Let me have a curly bracket, and let's write X. Let's have a slash, and let's say X greater than 5. Let me close the brackets. Now, what does this mean? This means that all the sets of x, all the sets of x, or sets of all x, such that, so this simply means such that, this slash straight slash symbol, this means such that. Okay, so such that x itself is greater than 5. Okay, so next, briefly, I'm going to take you through different type of numbers because we are going to need these in our part 2. So these are different types of numbers which you are aware of, but you should know the difference. We have a counting number, whole number, natural number, integers, rational numbers, irrational numbers, or real numbers. Well, these are not standard symbols. C might not actually necessarily depict counting number, but in this case I'm using that, and W here is for whole number. Okay, so counting numbers, just as the name implies, these are counting numbers. So something like, for example, 1, 2, 3, 4, 5. These are counting numbers. Okay, so so it's like saying a counting number is also an whole number but without 0. Okay, so because for whole number we can start with 0, 1, 2, 3, 4, 5. So this is an example of whole number. So now we go to natural numbers. So a natural numbers can be either a counting number, or a whole number. So meaning that you can have it as 1, 2, 3, 4, 5, or it could also start from 0, 1, 2, 3, 4, 5. So that is natural numbers. So the big ones now. What is an integer? So an integer, depicted by Z usually, can be a positive whole number. It can have the negative parts, and it also contains 0. So for example, we can have -2, -1, 0, 1, 2. So this is an integer. Okay, so what then is a rational number depicted by Q? First, you should know the definition of a rational number. A rational number is just like a fraction of two integers. Okay, let's say A over B. So where A and B are both integers. Okay, so but something very important you should take note of here is that the denominator in this case using B is not equals to 0. So it can be any other number. Okay, so you can have, for example, you can have 2 over 3. Okay, you can have -2, and so on and so forth. These are examples of rational numbers. What then is an irrational number? So basically, it's just like an opposite of a rational number. An irrational number in its own case cannot be written in a simple fraction. Okay, it cannot be written in a simple fraction like A over B. It cannot be expressed like 2 over 3. So a typical example of this in mathematics is what we generally know as pi, what we call pi. Okay, so pi in the real sense is a number like 3.14159, and the number continues. So when a decimal number has no end, like in this case of pi, is an irrational number. Another typical example that we often use is the Euler number depicted by E, like exponents. Okay, the Euler number. So the Euler number is also something like 2.71828, and it continues. So such number that you cannot necessarily write in a simple fraction is referred to as irrational number. So pi, when pi is used as 22 over 7, this is not an exact number, it's not an exact value, it's just like an approximation. the closest approximation to this number. So pi is an irrational number. And lastly, real numbers, it's just as the name implies, it's real, so it contains the whole number. It's going to be a rational number, it can be a irrational number, and so on and so forth. So this is going to be it for today. We're going to stop here, and like a little relationship between all these numbers, we can say natural numbers. If you look at the example, the element of a natural number can be found inside that of an integer, and all the elements of an integer can be found inside a rational number, and all the elements of a rational number can be found inside what we call the real numbers. In our next video, hopefully you will know the meaning of this symbol that is being used, the one that looks like C, an elongated C. Okay, so that's going to be it for today. I'm going to see you in the next video. In the next video, we'll look at certain examples using set builder notation. Thank you and see you. Stay tuned. Bye bye.
Please kindly subscribe. Thank you.